With the defeat of Germany on May 8th of 1945, the United States was in a precarious situation. Even with the steady destruction of its empire, Japan simply wouldn't surrender. The United States had two options: mobilize over 2 million men and invade the Japanese home islands, incurring nearly 1 million casualties and adding 2 years to the war, or use one of the most destructive technologically sophisticated weapons known to man. America chose the latter. On August 6th of 1945, the Enola Gay left the Northern Mariana Islands. Inside was a 15-kiloton gun-type fusion weapon loaded with over 145 pounds of highly radioactive uranium. Its name was Little Boy. 6 hours later, at the height of 31,000 feet, the first atomic bomb was dropped over the city of Hiroshima, with catastrophic consequences. But how exactly did the Little Boy atomic bomb work? What were the parts and mechanisms of the first nuclear bomb? What processes did it undergo during its detonation? Why was Hiroshima targeted? How big was the blast zone? How much of the city was destroyed? And most importantly, how many Japanese casualties were incurred when the first American atomic bomb reached its destination? Why was Hiroshima targeted? The target selection was subject to the following criteria. Number 1, the target had to be larger than 4.8 kilometers, or 3 miles in diameter, and was an important target in a large city. Number 2, the target would have to allow the blast wave to create effective damage. Number 3, the target was unlikely to be attacked by August 1945. When deciding which Japanese cities U.S. warplanners would target, there were 5 options. Kokura, the site of one of Japan's largest munitions plants; Hiroshima, an embarkation port, an industrial center that was the site of a major military headquarters; Yokohama, an urban center for aircraft manufacturing, machine tools, docks, electrical equipment, and oil refineries; Nagata, a port with industrial facilities including steel and aluminum plants; and Kyoto, a major industrial center. These cities were largely untouched during nightly bombing raids, and the Air Force agreed to leave them off the target list, so an accurate assessment of the damage caused by the atomic bombs could be made. Hiroshima was ultimately chosen for the following reasons. Number 1, it was an important army depot and port of embarkation in the middle of an urban industrial area. Number 2, it was a good radar target, and it was such a size that a large part of the city could be extensively damaged. There were adjacent hills around the city, which would considerably increase the blast damage. To understand how Little Boy works, we first need to understand the parts of the nuclear weapon. Located at the back of the weapon are the box-tail fins that stabilize the bomb when dropped from the air. Inside are 3 electric gun primers, which are the devices responsible for initiating the conventional charge that will push this projectile with an explosive force. Located here is the projectile tungsten carbide disc, and the most important part is the uranium-235 hollow projectile rings. The projectile ring slugs are hollowed and designed for the target rings to enter. They weigh around 89 pounds, while the front uranium target rings weigh around 56 pounds. Altogether, the bomb contains around 145 pounds of highly radioactive uranium. All these mechanisms and parts are encased in a 6.5-inch smoothbore gun barrel. At the nose of the bomb is the impact-absorbing anvil, and just above it sits the tungsten carbide plug, which contains 4 polonium initiators. The polonium initiators ensure a nuclear chain reaction occurs when the bomb is dropped. On the surface of the atomic bomb are barometric sensing ports and manifolds. The barometer identifies the precise altitude for detonation. Once the required altitude is reached, the barometer activates archie-fusing radar altimeters, which are these curvy-looking objects that prime the bomb for detonation. Now let's take a look at how this nuclear bomb works in basic step-by-step format. Step number 1. Before the bomb is dropped, all 3 arming plugs are pulled one after another. Step number 2. The bomb bay door is open, and the bomb falls due to gravity. When released, its internal 24-volt battery starts a timer. After 15 seconds, the bomb will be approximately 3,600 feet from the aircraft. Step number 3. Multiple radar altimeters are activated located at the front of the bomb. The barometric stage was added because of a worry that external radar signals might detonate the weapon too early. After activation, the barometer senses the desired height of around 580 meters, or 1,900 feet, as the Little Boy bomb was designed to be an airburst. Step number 4. To ensure accurate detection of the bomb's final altitude, multiple radar altimeters were utilized. This process involves measuring the altitude above the ground and beneath the bomb through the timing of radio wave travel and reflection. Once the correct height was sensed, the firing switch activates. Step number 5. The firing switch ignites 3 Navy gun primers in the breech plug. Step number 6. The 3 Navy gun primers set off an explosive charge, consisting of 4 soaked powder bags, each containing 2 pounds of cordite. Step number 7. The explosive charge launches the uranium projectile at 300 meters per second. Step number 8. 4 polonium initiators placed on tungsten carbide initiate nuclear reactions. Step number 9. This is where nuclear fission happens. An airburst detonation delivered from a single Little Boy atomic warhead, with a yield of 15 kilotons over the city of Hiroshima, had catastrophic consequences. Upon detonation, an immensely hot and luminous fireball was formed, expanding to a radius of 200 meters, vaporizing everything in its path. Those near the blast were evaporated, and within a 340-meter radius, all buildings were destroyed, killing 16,000 Japanese civilians in a matter of seconds. Very soon after detonation, multiple destructive blast waves developed, moving rapidly away from the fireball. The extreme radiation zone had a radius of 1.2 kilometers. Here, Japanese civilians received a 500 rem ionizing radiation dose, which was likely fatal in around 1 month's time. 15% of survivors would eventually die of cancer due to radiation exposure. Within a 1.7 kilometer radius, the shockwave emitted was measured at 5 psi, also known as a moderate damage blast zone. Here, most residential buildings collapsed, injuries were universal, and fatalities were widespread. Most commercial and residential fires started within this area, with damaged buildings spreading fire throughout the city. Within a 1.9 kilometer radius, due to the bomb's extremely high temperature, the shockwave emitted contained high levels of thermal radiation, causing third-degree burns in clothing to instantly ignite into flames. Third-degree burns extended throughout the layers of skin and were often painless due to the destruction of pain nerves. This left many with severe scarring or disablement, and in severe cases, often required amputation of burned limbs. As a result, around half the people between 340 meters and 2 kilometers from the blast were killed from debris, smoke, collapsed buildings, and radiation sickness, which translated roughly into an additional 67,000 Japanese fatalities over a period of 60 seconds. Within a 1.9 kilometer radius was the light blast damage zone. Here, damage was caused by shocks, similar to those produced by a thunderclap or a sonic boom, but with much more force. Although some windows were broken over 10 miles away, the injuries associated with flying glass generally occurred at overpressures of around 1 psi. This damage corresponded to a distance of around 3 miles, or 4.8 kilometers from ground zero, for a 15 kiloton nuclear explosion. The damage in this area of Hiroshima varied widely, as shockwaves rebounded multiple times off buildings, terrain, and even the atmosphere. As first responders moved inward, windows and doors were blown in, and gutters, window shutters, roofs, and lightly constructed buildings had increasing damage. Litter and rubble increased moving towards ground zero, and there was increasing numbers of stalled and crashed automobiles that made emergency vehicle passage difficult, raising the total death tally to 97,000 over a period of 60 seconds, with an additional 155,000 injured as well.